Hello, welcome to Algorithms. My name is Saurabh, and in this presentation, we are going to discuss about energy and power demand forecasting using machine learning on Azure platform. Now, the forecasting of demand plays a central role in the electric power industry, and there are a variety of methods for electricity demand prediction, ranging from those of the short term, like in minutes, to the long term in weeks. And in certain cases, they consider an individual consumer as well as at a macroscopic level, they do aggregation at the country level as well. Now, from the machine learning models perspective, you can use Gaussian process regression, linear regression, k nearest neighbor, random forest, and support vector regression to predict energy consumption. Now, we know that machine learning models produce pretty good energy consumption forecast, and hence, so you can use it if you are in a university. So your facility managers can use it. Utility companies and building commissioning projects can also use this architecture to implement energy saving policies. And so on and so forth. So let's look at the architecture part of it. Now, as you can see that we have different components, and in this case we are using sample data from the machine learning perspective. As I have said in the previous presentation, training data, validation data, testing data, 80-10-10 ratio. Now, from the components perspective, with stream analytics, we are using to aggregate energy consumption data in near real time and then write it to Power BI. Event Hubs ingest raw energy consumption data and passes it to Stream Analytics. Machine learning forecasts the energy demand of a particular region given the inputs received. Now, as I said in my previous presentations, which are specific to machine learning, it's very every architecture is very specific to what type of analysis you are trying to do. Similarly, there is a deep dive for machine learning as well, because this is a high level architecture, but if we talk about a specific machine learning algorithm, that's a deep topic in itself, because it really depends upon what data set you are using. Then how do we do the feature engineering and training, tagging of data, as I explained in my previous presentation, then training, validation, testing of the model, so on and so forth. But this architecture gives you an overview from the reference architecture perspective, that this is how you can implement. Now, there are alternatives as well, but this is what we are suggesting, because you might be using some of the components within your organization. So you can just you have the subscription, you can go start using these for POC, and then you can come up with your own model and your own architecture, but this is a good starting point. SQL database stores the prediction results received from Azure Machine Learning, and then these results are then consumed by Power BI. Data Factory actually handles the orchestration and scheduling of the hourly model retraining. So in this case, we are considering that our model is trained on the hourly basis. So you need to have a mechanism, and in that case, if you are not an ETL expert or data pipeline expert or big data expert, you need to rely on somebody within your team, or maybe a different team, to make sure that when they are creating data pipelines, you have to ensure that based upon your requirements, the model is getting trained based on what input you are providing or you have provided. Now, as we know, Power BI we are using to visualize energy consumption data from stream analytics, as well as predicted energy demand from SQL database. So this is a pretty simple architecture. The major complexity lies in the machine learning part, where you have to do a lot of research and then come up with a specific model, and that's where the rubber hits the road, because if your model is not good, then rest of the outcome is not useful in the production environment. So if you are a machine learning developer or a AI developer, then your focus is basically just the machine learning part, but there are other areas as well, like how do you architect the whole system from an enterprise architecture perspective or from a solution architecture perspective. So it is very good for those who are at the beginning of learning machine learning architecture, or how do you put together a solution for a machine learning environment. For them, this is a very useful presentation. It may not be very good for those who are developers, because for them, the interest is more towards, okay, which algorithm should I implement, and is there anything which we can leverage from the POC perspective, from the past experiments as well. So those are the things which we can provide as well, depending upon what you are trying to do. In some cases we do have some POCs, so we have got all the scripts and everything ready, but as I say, it really depends upon what type of data sets you have, what is your end goal, what is your business objective, so on and so forth, and at the end of the day, cost as well. So I guess this is it from my side. Thank you very much. Have a great day.